Hello everyone, this is Mr. McMillan, and I'm here with a little bit of an instructional review over the quadrilaterals properties. And the main reason I want to do this is because I'm working on filling out this flow chart that will be uploaded alongside this video. That way you have access to a good study chart for your review problems, okay? So the first bit here, of course, is that we're talking about the properties of quadrilaterals. And quadrilaterals, no matter what type that we're dealing with, is a polygon with 4 sides where the sum of the interior angles is 360 degrees. Okay, so all 4 of those inside angles, those interior angles, sum up to 360. It doesn't matter what type of quadrilateral you have. That's always true. All of them will add up to 360. But the first one we're going to talk about for the specific type of quadrilateral is a trapezoid. Okay, and a trapezoid is easily identified by the first property that it has, and that's basically what defines what a trapezoid is. And the trapezoid is the only type of quadrilateral that has exactly 1 pair of parallel sides. Okay, so as you can see in this diagram here, those little triangles, only 2 of those sides have it. So 1 pair of parallel sides is all a trapezoid will have. And you can see that if you were to extend those sides out to infinity, you would see that they would eventually cross, and so they cannot be parallel. The parallel sides, so in this case, these 2 sides, are called the bases. And one is called the upper base and one is called the lower base. Typically, the upper base is the smaller of the 2, and the lower base is the larger of the 2, or the longer of the 2. And the reason that is just because it's kind of like any type of structure. You set the largest part on the bottom, and then you narrow it up as you go along. The non-parallel sides, so these sides here, are called the legs. And then each pair of upper and lower base angles are supplementary. Okay, so each pair of upper and lower base angles are supplementary. So one is attached to the lower base, one is attached to the upper base. So they're above one another. Okay, they're connected by the same leg. So those always add up to 180 degrees. Okay, and going on down here, you can see there is a line attached, and it goes down to the isosceles trapezoid. Now, the isosceles trapezoid has all of the properties that a trapezoid does. So the 1 pair of parallel sides, it has bases, legs, and each pair of upper and lower base angles are supplementary. But it also has 4 additional properties that we concern ourselves with. And the first property that is unique to the isosceles trapezoid is that the lower base angles are congruent to one another. And as you can see in this diagram over here, we have these 2 angles, the lower base angles, are congruent to one another. Likewise, the upper base angles are congruent as well. So here and here, those 2 angles are congruent to one another. The legs of an isosceles trapezoid must also be congruent. And the reason that the shape is called an isosceles trapezoid is because of that 1 pair of parallel sides. You remember we talked about isosceles trapezoids and how isosceles meant that at least 2 of the sides were congruent. Okay, so that's the same thing for this trapezoid. And then finally, the diagonals. When we draw the diagonals in an isosceles trapezoid, we find that they are congruent as well. Okay, so the isosceles trapezoid, most of its unique properties have to do with things being congruent. So the lower base angles are congruent, the upper base angles are congruent, the legs are congruent, and the diagonals are congruent. All right, now we're going to focus on what the bulk of what we do with quadrilaterals is about, and that's the parallelograms. Okay, so the parallelograms, the rectangles, the rhombuses, and the squares. So for parallelograms, the thing that makes a parallelogram is that you have two pairs of opposite congruent sides, and those sides must also be parallel. So that's why it's called a parallelogram, because it has two pairs of parallel sides. So as you can see from the diagram, we have this side here and this side here are parallel and congruent to one another. And then the top side and the bottom side are parallel and congruent to one another. So two pairs of congruent and parallel sides. The opposite angles in a parallelogram are congruent, okay? And for opposite angles, when we talk about opposite angles, these are angles that do not touch one another unless they're connected by a diagonal. So if you look here, we can see this angle would be opposite this angle because they're not directly connected to one another unless we do it using a diagonal. The other way you can think about it is you have to draw two lines along the edge of the quadrilateral to get to it for it to be opposite. So here you have to draw one and then two lines to get to that angle, so that's the opposite angle. Likewise, this angle is opposite to this angle. The next bit, we can say that we have consecutive angles, and consecutive angles are always supplementary in a parallelogram, and that's true for any type of parallelogram. Okay, and consecutive angles specifically are ones that are attached by a side of the quadrilateral. So you'll see here this angle and this angle would be consecutive because you can draw one side of the quadrilateral to it. Likewise, this angle and this angle are consecutive, this one and this one, and this one and this one. And the last property that makes a parallelogram is that the diagonals bisect each other. Now you'll notice that there's nothing here about the diagonals being congruent to one another, and that's because for a regular parallelogram, that's not always the case, okay? So you see how this has some tilt in it? When it has some tilt in it, what it's doing is taking these two angles and stretching them further apart, making this diagonal longer, and bringing these two angles closer together, which makes this diagonal shorter. So the diagonals in a parallelogram will not be congruent. They will only bisect each other. They split each other in half. All right, next up we're going to talk about rectangles. And the key property that makes a rectangle is that every angle is a right angle. So every angle must measure 90 degrees. So if I say that you have a quadrilateral and it has 4 right angles, you know right away that it has to be at least a rectangle. It can also be a square, but you know it is a rectangle. Okay. About its diagonals, the diagonals are congruent in the case of a rectangle. And the diagonals also bisect each other. So the reason that the diagonals are congruent in a rectangle is because, unlike the parallelogram, the general case of parallelogram, there is no tilt to a rectangle. It's a box, right? So the corners have to be the exact same distance from one another. Now, a rectangle is also classified as and has all the properties of a parallelogram. So a rectangle has every single one of these properties in addition to the right angle and the congruent diagonals. So that you have two pairs of congruent sides, two pairs of parallel sides, the opposite angles are congruent, and the consecutive angles are supplementary. So a rectangle can always be classified as a parallelogram. All right, now let's look at a rhombus. And the key defining attribute of a rhombus is that it has 4 congruent sides. So every single one of the sides are the same length. Okay, so you can see that each one of these only has 1 tick mark, which means they are congruent. So if you have a parallelogram or a quadrilateral that has 4 congruent sides, you know immediately at minimum it has to be a rhombus. It could also be a square, but a rhombus doesn't require the angles to be a specific angle measure. All right, then the diagonals, the rhombuses, just like the parallelograms, you can see that the rhombuses have tilt in them. And since they have tilt in them, we cannot say that the diagonals are congruent to one another necessarily. Like if you look here, you see that this diagonal is much, much shorter than this diagonal here. Okay, so the diagonals are not congruent in a rhombus. However, the diagonals do bisect one another. And if you look here at their intersection, you can see that there is a perpendicular marking there, a right angle marking. So they're perpendicular. And they also bisect the opposite angles. So they split the angles opposite from one another into 2 congruent parts. And just like a rectangle, a rhombus can always be classified as a parallelogram. So it has all of these properties as well. It has 2 pairs of congruent sides and parallel sides. The opposite angles are congruent, the consecutive angles are supplementary, and the diagonals bisect each other. And then our last shape that we've talked about for the quadrilaterals, notice there is no kite on here. That's because we don't really concern ourselves with the kite. And we're going to talk about the square, okay? Now, of course, there are 2 defining characteristics that make the square up, and that is that it has 4 congruent sides and 4 congruent angles. So each angle is a right or 90-degree angle. So all sides must be congruent and all angles must be congruent to be a square. And a square, since it's basically a combination of all these types of shapes, it has every property that the diagonal can possibly have. So the diagonals are congruent. They are perpendicular. They bisect each other. And they bisect the opposite angles. So a square is the combination of a rhombus, a rectangle, and a parallelogram. It has every property that you could want out of a parallelogram. So anytime it asks like the properties, the only property that a square wouldn't have is 1 pair of parallel sides because it's got 2, okay? So it wouldn't have exactly 1 pair, it would have both pairs. And like I just said, it can be classified as a parallelogram, a rhombus, and rectangle. Okay? Now, there is something that I need to point out about this flow chart. If you look here, since it's a flow chart, you have lines that come from each box and go to their separate ways, or they connect in some way. Now you'll notice that since these do not connect in any way, okay, the quadrilaterals to the trapezoids and the quadrilaterals to the parallelograms, a trapezoid will never be a parallelogram, and a parallelogram will never be a trapezoid. Okay? So a trapezoid can never be a parallelogram, and vice versa, because they are never connected. There are no lines that directly lead to a trapezoid at all, right? If I follow this line here, I never can get to the trapezoid without starting back from the quadrilaterals, okay? So trapezoid will never be a parallelogram and vice versa. However, if you notice here, there is an arrow on the right, a double-headed arrow, and the bottom says sometimes and the top says always. So what that means is that as we go further up, so we start from the bottom and go further up, those quadrilaterals will always be those other quadrilaterals. So for instance, a square starts down here and it's connected to both a rectangle and rhombus. So a square is always a rectangle, it's always a rhombus. And then you can go further and say that a square is always a parallelogram. And then you can say that a square is always a quadrilateral. However, since it's not connected directly to the trapezoid, you can't say that a square would ever be a trapezoid, okay? Likewise, you could see that the isosceles trapezoid would be always be a trapezoid, which is always a quadrilateral. Now, in comparison, if you went down, so you could see that a parallelogram would sometimes be a rhombus, or sometimes be a rectangle, or sometimes be a square, but not always, okay? Now, a rhombus and a rectangle could also be one another. So a rhombus could sometimes be a rectangle, but only if it's a square, okay? So hopefully this flowchart does help you. You know, I hope it proves to be a good study tool. Through the rest of this packet that's on there, the review, we're going to be working on it. We worked on it today, but we're also going to work on it the next lesson. So there's a bunch of problems. The first 15 or so are on the properties, and then the rest are like math problems, like applying what you know about the properties to each thing, okay? So I hope this video helped, guys. And as always, if you need help, please email me, let me know. We can always schedule a Zoom session one-on-one. I've been helping many people with those. So yeah, thanks guys, and I'll see you in the next video.